reduce the risk of wildfire in the wildland urban interface area. So I have a little land acknowledgement too. The data that I'm going to be speaking to was collected and the research learnings and report development on it all took place on the ancestral and traditional territory of the Ktunaxa Nation, home to the Ktunaxa people, which has always been a land of teaching, learning, and research. So the data and the reporting behind it was all collected and developed using primarily Western methods, concepts, and theories. But when we braid these together, our modern Western science and the traditional ecological knowledge helps provide a basis for ecological and cultural reconciliation. So just a little acknowledgement there. So a little bit about the project history. So in 2017-18, there were some really difficult fire seasons that we experienced. But one of the learnings that came out of these difficult years was a notice of the value of agricultural practices, specifically grazing, in helping to change fire behavior by slowing, turning, or stopping fires. And so these were considered sort of agricultural fire breaks. So with this knowledge in hand, the British Columbia Cattlemen's Association partnered with the province and ranchers to help develop a pilot program to investigate wildfire risk reduction using this targeted grazing methodology. And the whole impetus behind this is that we're going to use targeted cattle grazing to reduce or break up fine fuel loads and wildfire risk next to communities, utilities, and transportation corridors. The research that we've done so far has been focused really on that wildland urban interface area next to community infrastructure. So I want to talk a bit about what targeted grazing is and why we're using it. So targeted grazing actually does have a specific definition behind it. It's the use of a specified kind of livestock at a determined season, duration, and intensity to accomplish defined vegetation and landscape goals. And so targeted grazing is a good complementary layer to wildfire risk management, because most of the fuel management projects and practices done in British Columbia specifically are focused on tree canopy characteristics. Because those crown fires are really those devastating things. So a lot of the work is around the removal of trees, decreasing the number of trees per hectare, changing your species, and or pruning or removing the understory, which is good because it helps reduce those sort of really problematic, like highly dangerous crown fire issues. But one outcome of that is that you do have increased herbaceous material. Once you open up the canopy, you have more light resources, water resources, and you get this flush of largely grasses in the southern interior of British Columbia. And then of course, when those cure and dry, they become this, like, they're basically a tinderbox, right? They're volatile and easily ignited fuel types. And then of course, when you're in the urban interface area, you have a lot of people in there, and people sometimes tend to start fires either accidentally or on purpose. So the reasoning behind this whole project was to reduce those fine fuel loads that come following those thinning opportunities, or break up the fuel continuity. And then the other key piece of it was that we wanted to ensure that other important ecological goods and services that rangelands provide aren't negatively impacted by this targeted grazing. So that in the British Columbia context, that means that we want to adhere to stubble heights and forage use levels that are prescribed through the province. All right, so how did we do this? Well, I should mention that I'm a co-researcher with Dr. Reg Newman, and he created this incredible experimental design that we implemented across 4 different sites that were established in 2020. And so these included Peachland, Summerland, and then there were 2 study sites located in Cranbrook. And today I am going to be speaking on the Cranbrook East pilot specifically, because it's, we don't have a ton of time, and I want to be able to present some actual results. So monitoring occurs sort of in this area of interest, which is within 2 kilometers of the infrastructure of concern. So in this case, it was 2 kilometers from the community boundary. And then intensive data collection, which is where we focus a lot of our effort is concentrated within 400 meters of that community infrastructure. And this distance is used province-wide by the BC Wildfire Service for wildfire prevention planning around communities. And the monitoring, of course, has those two components: intensive monitoring, which occurs once a season at those more intensive monitoring macro plots. And that occurs after grazing, and then extensive monitoring, which occurs every 2 weeks during the grazing period. So the extensive monitoring, it occurs in that larger area, gives broader coverage of the pilot site, and is intended to provide information on whether or not the grazing activity is having negative impacts on the plant communities or the resources associated with them. And that's so that we can ask for adaptive management to occur and, prevents any sort of negative impacts from the treatment. So this looks like the extensive monitoring is all of these little plots here where we look at leading plant species height, estimated percent cover, wanting to ensure that we're not exceeding those stubble height requirements. We're looking at grazing use, fuel continuity characterization to have an idea of how fire may carry across it, and also includes riparian health assessments, because riparian areas are often where we have congregations of livestock. And then, of course, we look at other plot attributes such as slope, aspect, et cetera, et cetera. The intensive design is of course, quite a bit different. So we have these randomly selected macro plot areas within that close to the community infrastructure boundary. And it's very quantitative data. It allows us to make statistical inferences, and it occurs after grazing is completed for the season. And of course, we needed to be able to sort of quantify the grazing use. So we have forage cages out there to provide a non-grazed comparison. And then we have a host, we have 16 different variables that we review through this intensive monitoring design. Everything from biomass, like both living and your litter. We have plant identification using transects to track species composition shifts and changes over the life cycle of the project to ensure that we're not having, increaser species come in and our decreaser species all leave. We're looking at, bare soil, woody fuel, which is also an important component of wildfire risk mitigation. And then we're also looking at things like fuel moisture content to have an idea of what our moisture levels are. And then, of course, looking at different range health variables as well. So for the Cranbrook East site, these are where our 3 macro plot locations were. You can see them in orange there. So they're randomly located in that area right adjacent to the community. And this is what the macro plot design looks like. We have these forage plot segments where we have cages and then an uncaged pair associated with it. We have Daubenmeier transects, 5 of them. And that's also where we assess our range health and our conifer region. And then we also look at stubble height and fuel continuity along a 100-meter baseline transect. So there's an awful lot of data that comes out of this. It's very intensive, and we've been getting some excellent results out of it. So plant community characterization is actually a really important piece of this because it allows us to monitor community changes and any shifts in ecological status or integrity. And this is monitored annually as the project moves forward to see if the targeted grazing treatment causes any of those composition shifts that maybe we're not looking to have occur from a grazing treatment. So on the Cranbrook East site, we had this area was classified as a fir western larch pine grass twin flower community of the IDF BM2. And we also had a western fescue component in there. So the plant community specifically was, Douglas fir, western larch with Oregon grape and pine grass, as well as western fescue. The study site has been in good health overall. The plant communities are dominated by these really vigorous native species that are indicative of forested and seeded agronomic communities, mainly pine grass communities that are quite vigorous and growing great really once the overstory has been opened up. And one thing we found throughout the extensive monitoring as well as the intensive monitoring was the targeted grazing treatment in 2020 found an overall grazing use of about 24% across the study area, which is pretty in line with what what you would like to see for grazing use in the East Kootenays. So some of this is intensive results from our biomass clippings, both caged and uncaged. So caged would be that grazed one and uncaged would be your non-grazed comparison. We found that total biomass, of course, was significantly different. So there was a 40% reduction in your living biomass in the grazed versus non-grazed treatment, and a 25% reduction in total biomass. And so that takes into consideration your litter, of course. So litter biomass is interesting because it was significantly different between the grazed and the non-grazed, but not in the way that we expected. So we actually, of course, anticipated that we would have more litter in your non-grazed samples, but this year or in 2020 for some reason, we found that in the grazed samples there was more litter rather than in the non-grazed samples, and this could be potentially due to grazing effects, where maybe the cattle were kind of leaving pieces of biomass and that had been living and it turned into litter. I'm not quite sure, but it was really interesting. Or it could have been an issue with plot pairing, because litter is one of those really key indicators. And when you start to have your litter be reduced, then it's an indicator that your range health is going to start to decline as well. And there might be some overuse associated with it. So it's quite interesting that in the grazed plots, we were seeing a reduction in living biomass, but we were seeing an increase in litter. So strange, but stay tuned for what 2021 tells us. So also Stubble Heights, of course, are really important. They are an indicator of the level of use across an area. And so our stubble height analysis showed that there was a 34% height reduction in pine grass in the grazed samples relative to the non-grazed controls. But our average minimum stubble heights were never lower than recommended minimum stubble heights for any of the plots. And so for pine grass, the province recommends a minimum height criteria of 18 centimeters. And so you can see even in our grazed samples, we were still seeing an average height of 22.7 centimeters. So of course, there's a reduction between your grazed versus your non-grazed, but we were still above the minimum heights. And so that kind of lets us know that we're not overusing the area. So that's just a bit of an overview of a couple of the different results that we saw. This is all still in very preliminary stages. We've been working on determining or the analysis of the 2021 data. And, we're excited to see what those show, but I don't quite have them ready yet. So of course, talking about 2020 stuff here. So in summary, grazing in the 400-meter zone was considered moderate. We weren't seeing, huge issues with overgrazing. If there had been, 70% use of biomass, I would probably be going, oh my gosh, stop. But we didn't see anything like that. Stubble heights were moderately reduced, but they weren't reduced to anywhere that would be considered a problem or a concern. So yeah, we had our total biomass reduction around 25%, and then heights reduced by 34%. So this tells us that we're not negatively impacting the resource, but that grazing impacts would likely have a moderate effect on fire behavior in that critical 400-meter zone through those reductions in fine fuel biomass and then the height. So that has implications on your flame length and your rate of spread and intensity of fire. So a couple of conclusions and considerations. These are really preliminary results and they require ongoing monitoring. It also tells us that livestock grazing is likely effective in addressing fine fuel management concerns. And we were able to identify our primary range areas, characterize our current plant communities, which is important to track shifts over time, and to assess whether there's any negative impacts to ecological status or integrity. So what we're doing now this year is we're using this data to model fire behavior to test whether the targeted grazing impacts are having quantitative effects on things like flame height and rate of spread. We kind of instinctively, that if your grass biomass, the amount is reduced and the height is reduced, it's likely to have impacts on fire behavior. But we're currently working with some modeling specialists to have that, have some quantitative results on that. So I'd like to acknowledge a couple of different organizations and people. So funding support was provided through the Canadian Agricultural Partnership, the Ministry of Forest Land, Natural Resource Operations and Rural Development, as well as the BC Wildfire Service for this project. And also special thanks to the lead researcher, Dr. Reg Newman. Shauna Larad is the range officer for the Rocky Mountain District, and she's helped out a ton in getting this moving and off the ground. And the tenure holder for the East Cranbrook site is Jordy Thibault, and he's been excellent in, targeting his cattle on those areas and assisting with the project. And last but not least, this is kind of, I think, a great way of illustrating the issue that we're trying to address. So, if you look on the right in this reference area exposure, you see a lot of dead overgrown grass, and it's definitely looking a bit like a tinderbox. So that's something that we don't want to see. And then you look to the left and you have something that looks like a potentially unhealthy grassland ecosystem, which is also not what we want to have as an impact or as an outcome from targeted grazing in our, really critical BC grassland systems and open forest systems. So what we're trying to do is to find a happy medium between having overuse and potential negative impacts on ecosystem function, and then but still being able to accurately and adequately address the fire hazard associated with having a ton of fine fuel on the landscape. So that is all I have to say on that.